The Bermuda Triangle is a loosely defined area in the western North Atlantic Ocean. The Bermuda Triangle's boundaries are roughly defined by Bermuda, Florida, and Puerto Rico. This region is a busy waterway with frequent maritime and aerial traffic. The Gulf Stream, a strong ocean current, flows through the Bermuda Triangle. The Gulf Stream can cause rapid changes in the marine environment. Strong ocean currents contribute to navigational challenges in the Bermuda Triangle. The open ocean is subject to unpredictable and severe weather patterns. Tropical storms and hurricanes are significant weather risks in this area. These extreme weather events pose considerable dangers to ships and aircraft. Magnetic anomalies in the Bermuda Triangle may cause compass deviations. These compass deviations can complicate navigation in the region. Unusual magnetic variations are reported in the Bermuda Triangle. Methane hydrates exist on the seabed within the Bermuda Triangle. The sudden release of methane hydrates can decrease water density. Decreased water density can potentially destabilize ships. Rogue waves are unexpectedly large and powerful waves that occur in open ocean environments. These waves pose a significant threat to vessels due to their potential to cause sudden capsizing. Rogue waves can also inflict structural damage on ships due to the immense force they exert. Many incidents attributed to the Bermuda Triangle may stem from human error. Navigational mistakes represent a significant factor in reported Bermuda Triangle incidents. Inadequate training may contribute to incidents within the Bermuda Triangle. Mechanical failures can lead to disappearances, particularly in older vessels lacking advanced technology. Equipment malfunctions are a plausible explanation for incidents involving older ships and aircraft. The absence of modern technology increases the risk of equipment-related incidents and subsequent disappearances. Seismic activity on the seabed can trigger tsunamis, posing a threat to surface vessels. Underwater landslides can cause sudden changes in the seabed, affecting surface vessels. Tsunamis and seabed changes represent potential geological hazards for maritime navigation. Waterspouts are essentially tornadoes that form over water. Waterspouts can develop quickly, posing a threat to ships and low-altitude aircraft. The rapid formation of waterspouts creates hazardous conditions in open water environments. Navigational hazards, such as strong currents, pose significant challenges for sailors. Magnetic anomalies can disrupt compass readings, further complicating navigation. The convergence of these hazards makes navigation particularly difficult for inexperienced sailors. Historical disappearance records contain documented facts and sensationalized accounts. Distinguishing between verifiable information and sensationalism is crucial when reviewing historical records. Focusing on documented facts allows for a more accurate understanding of historical disappearances. The disappearance of Flight 19, a squadron of U.S. Navy bombers, remains an unsolved mystery. Pilot error is considered as one potential factor contributing to the loss of Flight 19. Adverse weather conditions may have played a significant role in the Flight 19 incident. The Star Tiger and Star Ariel were two British South American Airways planes that disappeared without a trace. Investigation focuses on identifying common factors or clues that might explain the disappearances. Archival records are meticulously examined for any anomalies or overlooked details. Statistical analysis is used to compare incident rates in the Bermuda Triangle with those in similar regions. Traffic volume is a key variable to control when comparing incident rates. Environmental factors, such as weather patterns and magnetic anomalies, must also be considered. Maritime insurance rates are analyzed to determine if premiums differ for vessels traversing the Bermuda Triangle. Insurance records are examined to compare historical loss data inside and outside the Bermuda Triangle. Statistical models are used to assess the correlation between location within the Bermuda Triangle and increased insurance risk. Search and rescue operations involve systematic efforts to locate and assist individuals in distress. Environmental challenges, such as rugged terrain and inclement weather, significantly impede search efforts. The likelihood of finding wreckage is statistically modeled based on environmental factors and search area coverage. Modern navigational tools like GPS enhance safety by providing precise location data. Advanced radar systems detect and display potential hazards, improving situational awareness. These technologies mitigate risks associated with the Bermuda Triangle by improving navigation and hazard avoidance. Satellite monitoring tracks weather patterns in the Bermuda Triangle using advanced sensors. Ocean currents within the Bermuda Triangle are monitored via satellite to understand their complex dynamics. Satellite surveillance identifies and tracks vessel movements within the Bermuda Triangle. Oceanographic research focuses on understanding the unique environmental conditions of specific marine areas. geological features of the ocean floor mapped and analyzed to reveal underwater landscapes and formations. Research vessels are equipped with advanced instruments to collect and analyze marine data. Pilot training simulations prepare pilots for the unique challenges of flying over the Bermuda Triangle. Weather simulations replicate the unpredictable and severe weather conditions common in the Bermuda Triangle. Navigation training addresses the magnetic anomalies and navigational difficulties specific to the Bermuda Triangle. Modern ship designs incorporate features that enhance stability in rough seas. Enhanced stability features reduce the risk of maritime incidents in challenging areas. Safety measures integrated into ship design mitigate potential hazards in regions known for maritime challenges. Reliable communication systems are vital for vessels and aircraft in distress. Effective communication facilitates timely search and rescue operations. Communication systems ensure that distress signals are accurately relayed to rescue teams. Data analysis involves a comprehensive review of available information to identify patterns. Weather data, navigational records, and incident reports are key information sources for analysis. Identifying patterns in data can lead to potential explanations and insights. The Bermuda Triangle presents unique navigational challenges due to its geographic location and weather patterns. Natural causes, such as strong currents and unpredictable weather, can account for many incidents in the Bermuda Triangle. Human factors and errors, rather than extraordinary phenomena, are often significant contributors to incidents within the Bermuda Triangle.
The Voynich Manuscript is a unique codex of unknown origin, language, and purpose. The manuscript's author and the language in which it is written remain unidentified. Its physical characteristics include a distinctive size, binding, and aged condition. Parchment age can be determined through carbon dating, analyzing the decay of carbon-14 isotopes within the material. Scientific methods, including ink and pigment analysis, provide insights into the manuscript's origin and period. Detailed examination of the parchment material reveals its composition and manufacturing techniques. The Voynich manuscript features a unique writing system with unknown characters. Analysis of the script reveals distinct character shapes, frequencies, and statistical properties. Despite numerous attempts, the Voynich manuscript script remains undeciphered. Botanical illustrations depict plants, some of which do not correspond to known species. The origins of these fantastical plants could be artistic license or representations of undiscovered species. Interpretations of these illustrations range from symbolic representations to speculative botany. Astronomical illustrations depict celestial bodies and zodiacal charts. Medieval astronomy and astrology are potentially related to these illustrations. Analysis reveals potential connections between the illustrations and historical astronomical knowledge. The illustrations depict nude female figures within interconnected tubs or channels. These illustrations may represent alchemical processes, medicinal practices, or ritual bathing. Interconnected channels suggest a system of transformation or purification. Pharmaceutical illustrations depict labeled containers and plant parts. Analysis reveals connections between these drawings and medieval medicinal practices. The illustrations reflect the influence of herbalism on pharmaceutical knowledge. The Voynich manuscript is situated within the intellectual and cultural landscape of medieval Europe. Alchemy, astrology, and medicine were influential disciplines during the historical period of the manuscript's creation. Understanding these disciplines provides context for interpreting the manuscript's mysterious content and purpose. The manuscript's known history begins with its rediscovery in the early 20th century. Wilfrid Voynich played a key role in bringing the manuscript to public attention. The manuscript's origins and previous owners remain largely unknown before its rediscovery. Statistical analysis, including frequency analysis, is applied to the Voynich script to identify patterns. Entropy calculations are used to measure the randomness and complexity of the Voynich script. Despite statistical analysis, the Voynich script has not been successfully deciphered. Substitution ciphers involve replacing each symbol in a manuscript with a letter or syllable to decode the text. Early decipherment attempts often relied on frequency analysis, assuming common symbols represented frequent letters like E or T. The failure of simple substitution methods suggests the manuscript employs more complex encryption or a different language structure. Polyalphabetic ciphers, such as the Vigenère cipher, have been applied in attempts to decipher the Voynich manuscript. The complexity of the Voynich script has made it resistant to decryption using standard polyalphabetic methods. Despite numerous attempts, No definitive breakthrough in deciphering the Voynich manuscript using polyalphabetic ciphers has been achieved. Microscopic analysis of ink can reveal the sequence in which text and images were applied to parchment. Analyzing the relative positioning of ink and image elements helps to determine the manuscript's construction process. The order of creation provides clues about the manuscript's original design and potential alterations over time. The Voynich script may represent a constructed language, potentially created for esoteric or artistic purposes. A constructed language is an artificially created language, as opposed to a naturally evolved one. Proving the Voynich script is a constructed language presents significant challenges due to the absence of a Rosetta Stone or clear linguistic structure. One theory suggests the Voynich manuscript encodes a natural language using a complex cipher. Potential source languages for the Voynich manuscript include Latin, Arabic, or a constructed language. Cipher systems potentially used in the Voynich manuscript range from simple substitution to polyalphabetic and homophonic ciphers. The Voynich manuscript may be a deliberately fabricated hoax, intended to deceive or entertain. Motivations for a hoax could include financial gain, fame, or simply the enjoyment of creating a puzzle. The feasibility of a hoax depends on the creator's skill in linguistics, botany, and cryptography. Manuscript inks are composed of various elements and compounds, analysis of which reveals historical ink-making practices. The presence of iron gall tannins indicates the use of iron gall ink, a common writing material in historical manuscripts. Variations in ink composition can provide insights into the origin, age, and authenticity of historical documents. Pigment identification involves analyzing the chemical composition of colorants used in illustrations. Pigments can be derived from various sources, including minerals, plants, and animals, each with distinct historical usage. Pigment analysis provides clues about a manuscript's origin by revealing the materials and techniques available at the time and location of its creation. Machine learning algorithms are applied to the Voynich script to identify potential patterns. Attempts to translate the Voynich script using machine learning face significant limitations. Despite limitations, machine learning offers potential avenues for future Voynich script analysis. The Voynich manuscript can be compared to illuminated manuscripts based on its visual style. Unlike herbals, the Voynich manuscript's plant depictions do not correspond to known species. Similar to alchemical texts, the Voynich manuscript contains symbolic diagrams, but their meanings remain undeciphered. Steganography allows for hidden messages to be embedded within illustrations or text. Steganographic methods involve concealing data in such a way that its presence is not apparent. Detecting steganographic elements requires specialized tools and techniques to analyze data patterns. Polygraphic substitution involves replacing groups of characters with other groups to encode or decode text. This method aims to enhance security by obscuring individual letter frequencies, making cryptanalysis more challenging. Successful application requires a predefined substitution table or algorithm known to both sender and receiver. Pareidolia is a psychological phenomenon where the brain perceives patterns in random or ambiguous stimuli. This phenomenon can influence the interpretation of ambiguous information, such as ancient manuscripts or abstract art. The brain's tendency to seek familiar shapes and meanings can lead to subjective and varied interpretations of the same stimulus. The Voynich manuscript's enigmatic nature has inspired numerous modern artists across various mediums. Writers and filmmakers have incorporated the manuscript into fictional narratives, exploring its potential secrets and mysteries. These artistic works often reimagine the manuscript's illustrations and text, creating new interpretations and narratives. The Voynich manuscript remains one of the world's greatest unsolved mysteries. Current research continues to explore the manuscript's potential origins, purpose, and meaning. Future investigations may utilize advanced technologies to decipher the manuscript's secrets. The pyramids served as monumental tombs for pharaohs in ancient Egypt. These structures symbolize the pharaoh's power and divine status. Pyramids held significant religious and political importance in ancient Egyptian society. Ancient Egyptians employed sophisticated architectural plans to determine the pyramid's dimensions. Surveying techniques were crucial for accurately orienting the pyramid. The construction of pyramids required advanced mathematical knowledge and precision. The quarrying process involves extracting massive limestone blocks from bedrock. Copper chisels are used to separate the limestone blocks. Dolerite hammers assist in the extraction of limestone blocks. Granite, a hard and durable stone, was quarried in Aswan for specific construction purposes. The hardness of granite made it suitable for key structural elements within the pyramids, such as the King's Chamber. Quarried granite was transported north from Aswan to the pyramid construction sites. Stone shaping methods ensure precise dimensions for pyramid construction. Stone dressing techniques create smooth surfaces for a tight fit. Precise stone shaping and dressing are essential for a structurally sound pyramid. Stone blocks are transported from the quarry to the pyramid construction site. Wooden sleds facilitate the movement of heavy stone blocks. Lubricated pathways reduce friction during transportation. Ancient Egyptians utilized boats to transport large stone blocks along the Nile River. The transportation of heavy stone blocks presented significant logistical challenges. Water transport was essential for moving materials over long distances in ancient Egypt. Ramp systems, including straight, spiral, and zigzag designs, facilitated the elevation of stones during pyramid construction. Straight ramps offer direct but steep ascent, requiring significant force to move heavy stones. Spiral and zigzag ramps reduce the gradient, distributing the workload over a longer distance and gradual ascent. Lever systems are utilized to lift heavy stones during pyramid construction. Mechanical devices enable precise positioning of stones on each course of the pyramid. The combination of levers and other mechanical aids facilitates the accurate placement of stones. Stone placement involves meticulously fitting each block to ensure tight joints and proper alignment. Precise measurements are essential for achieving accurate stone alignment and structural integrity. Adjustments are made to each stone to achieve a seamless fit with the surrounding stones. Fine white limestone casing stones were used to create a smooth, reflective outer surface for the pyramid. The limestone casing stones were precisely cut to ensure a tight fit and smooth surface. The precise fitting of the casing stones created a continuous, reflective surface across the pyramid's exterior. The pyramids demonstrate remarkable astronomical alignment with cardinal directions. Some pyramids are oriented towards specific stars, reflecting advanced astronomical knowledge. The precise alignment suggests a deep understanding of astronomy and surveying techniques. The pyramid's internal chambers served specific functions, such as housing, sarcophagi, and ritual spaces. Passageways within the pyramid connected chambers and facilitated ventilation. Construction techniques involved precise stone placement and structural support systems. The King's Chamber features a sarcophagus, central to its design and purpose. Massive granite blocks form the chamber, showcasing the scale of ancient construction. The chamber's construction demonstrates remarkable precision in ancient stone masonry. The Queen's Chamber is a significant internal structure within the pyramid complex. Various theories exist regarding the Queen's Chamber's intended function and symbolic importance. The chamber's unique architectural features contribute to the ongoing debate about its purpose. The Grand Gallery is a corbelled passageway leading to the King's Chamber. Its unique architectural design features corbelled walls that create a gradually narrowing passage. The corbelled construction supports the roof and distributes the weight of the structure. Pyramid construction involved a diverse workforce, including skilled laborers responsible for cutting and shaping stones. Engineers and architects played a crucial role in planning and overseeing the construction process. Overseers managed the workforce and ensured the project adhered to the planned schedule and design. The workforce was organized into work gangs to enhance efficiency and productivity. Provision of food and shelter was essential for maintaining a healthy and productive workforce. Tools were provided to work gangs to enable them to perform their tasks effectively. Copper chisels were used to precisely shape the pyramid stones. Stone hammers aided in the rough shaping and breaking of larger rocks. Ropes and sleds were essential for moving massive stones across the construction site. Pyramid construction involves distinct phases: planning, quarrying, transportation, and assembly. The initial planning phase includes site selection, design, and resource allocation. Quarrying and transporting massive stone blocks were critical and labor-intensive processes. The pyramid complex comprises the pyramid, mortuary temple, causeway, and valley temple. The mortuary temple served as a place for rituals and offerings dedicated to the deceased pharaoh. The causeway connected the mortuary temple to the valley temple, facilitating the transportation of the pharaoh's body. Mortuary temples served as sites for rituals and ceremonies honoring deceased pharaohs. These temples exhibit distinctive architectural features, reflecting the religious beliefs and artistic skills of ancient Egyptians. Mortuary temples held significant religious importance, acting as a bridge between the earthly and spiritual realms. The causeway is a raised pathway connecting the mortuary temple to the Valley Temple. The causeway served as a route for funerary processions. The causeway facilitated the transportation of the deceased and offerings to the mortuary temple. The Valley Temple was located near the Nile River and served as a crucial site for Pharaoh's funerary rites. The pharaoh's body underwent preparation for burial within the Valley Temple. The funerary procession commenced at the Valley Temple, marking the beginning of the pharaoh's journey to the afterlife. Pyramid construction showcases the ingenuity of ancient Egyptian engineering. The construction of pyramids required immense organizational skills and logistical planning. The enduring pyramids stand as testaments to the dedication and perseverance of the ancient Egyptians. Turkmenistan's Karakum Desert is characterized by its expansive, arid landscape. The Darvaza gas crater is centrally located within the Karakum Desert. The Darvaza gas crater is situated far from major settlements. The desert's subsurface comprises layered sedimentary rock formations. Significant natural gas deposits, primarily methane, are contained within these rock layers. These subsurface deposits represent a substantial source of natural gas resources. In 1971, a Soviet geological expedition initiated a drilling operation in Siberia. Accidental puncturing of a subsurface gas pocket occurred during the drilling process. The gas pocket rupture led to a structural collapse at the drilling site. Drilling operations can destabilize subsurface structures, leading to ground collapse. Ground collapse results in the formation of a large crater at the surface. Craters formed by drilling can release significant quantities of methane gas. In 1971, geologists identified escaping methane as a potential environmental hazard. The methane leak posed safety risks to nearby communities. An initial assessment determined the severity of the methane risk. In 1971, a decision was made to ignite the methane gas to mitigate the associated risks. The controlled burn was initiated with the expectation that the methane gas would dissipate within a few weeks. Ignition was chosen as a method to safely manage and eliminate accumulated methane. The gas crater has been burning continuously since 1971. The continuous burning has far exceeded initial estimates. The gas crater has become a prominent landmark. The Darvaza crater measures approximately 70 meters in diameter. The crater's depth reaches approximately 30 meters. The Darvaza crater is a significant depression in the desert landscape. Methane, CH4, is the primary component of the burning gas. The gas also contains smaller amounts of other hydrocarbons. Gas analysis identifies the specific hydrocarbons present and their relative concentrations. The burning process involves the oxidation of methane. Methane oxidation produces carbon dioxide, CO2, water, H2O, and heat. Combustion is an exothermic reaction, releasing energy in the form of heat. Combustion processes release substantial quantities of CO2 into the atmosphere. Elevated CO2 levels in the atmosphere contribute to increased greenhouse gas concentrations. The increase in greenhouse gases directly drives climate change and global warming. Combustion byproducts affect local air quality around the crater. Local ecosystems are potentially impacted by air pollution. Air pollution poses risks to human health in the surrounding areas. The continuous burning of natural gas represents a significant waste of resources. This wasted natural gas could be used for energy production. Burning natural gas leads to energy loss and environmental pollution. The Darvaza gas crater has become a unique tourist attraction. Tourists are drawn to the crater's unusual and dramatic appearance. The attraction is a result of the crater's fiery and otherworldly aesthetic. Scientists have undertaken expeditions to investigate the crater's geological composition. Microbiological studies have been conducted to analyze the crater's unique microbial life forms. Explorers have studied the combustion dynamics within the crater environment. Extremophile bacteria are capable of thriving in extreme environmental conditions. These bacteria have been found in the hot, methane-rich environment of the crater. Research confirms the presence of microbial life in extreme geological formations. Various proposals aim to extinguish the fire by capping the crater. Another proposed solution involves extracting the remaining gas to eliminate the fuel source. Both capping and gas extraction represent potential methods for controlling and ultimately extinguishing the fire. Capping the crater involves significant technical challenges. High temperatures pose a major obstacle to capping operations. Unstable ground and continuous gas flow further complicate the capping process. Extracting remaining gas for energy production is a potential solution. This solution requires substantial investment in infrastructure, and technology. A feasibility analysis is crucial to determine the viability of gas extraction. Utilizing gas resources presents potential economic benefits for Turkmenistan. Economic gains must be carefully balanced against potential environmental costs. Sustainable practices are crucial to mitigate environmental impact while harnessing gas resources. The Turkmen government is exploring environmental policies to mitigate the crater's impact. Sustainable energy practices are being promoted as part of the government's environmental initiatives. These policies aim to balance environmental protection with energy production. International experts are consulted to evaluate the situation. Expert consultations provide recommendations for mitigating environmental impact. These recommendations aim to reduce the negative effects on the environment. The future of the Darvaza gas crater requires sustainable solutions that balance environmental concerns and economic opportunities. Environmental mitigation strategies include capturing and utilizing the methane gas to reduce greenhouse gas emissions. Economic opportunities involve developing ecotourism and renewable energy projects in the surrounding area. Advanced monitoring systems are deployed to track environmental conditions around the crater. These systems monitor gas emissions, providing real-time data on atmospheric composition. Monitoring systems also track air quality and ground stability to assess environmental impact. Long-term ecological restoration efforts are essential for mitigating environmental damage. Ecological restoration aims to promote biodiversity in the surrounding desert ecosystem. Restoration projects require sustained commitment to reverse degradation and foster a balanced ecosystem. Area 51 is located within the Nevada Test and Training Range, a large, restricted military area. The remote location of Area 51 contributes to its secrecy and mystique. The Nevada Test and Training Range is a vast area used for military training and development. Area 51 is situated within the Nevada Test and Training Range. The map shows Area 51's geographical relation to surrounding towns and landmarks. Detailed cartography provides geographical context for Area 51 within Nevada. Area 51's origins trace back to the 1950s during the Cold War era. The US government needed a secure, isolated location for advanced aircraft development and testing. The primary purpose of Area 51 was to develop and test advanced aircraft technology during the Cold War. The base served as a key site for the development of the U-2 spy plane. The U-2 aircraft was designed for high-altitude reconnaissance missions. The U-2's primary mission was to conduct surveillance over Soviet territory. Declassified documents reveal Area 51's official purpose as a testing site. Area 51 served as a ground for experimental aircraft development. The site was also used for the testing of advanced weapon systems. Area 51 is heavily guarded, including restricted airspace to prevent unauthorized access. Perimeter fences equipped with surveillance cameras surround the facility to deter intruders. Armed security personnel patrol the grounds, providing an additional layer of protection. Warning signs clearly indicate severe penalties for unauthorized entry. The presence of warning signs emphasizes the high level of security surrounding the base. Unauthorized entry results in strict legal consequences. Advanced surveillance technology is used to monitor the perimeter. Cameras and sensors are key components of the surveillance system. The system is designed to detect any unauthorized activity. A prevalent conspiracy theory suggests Area 51 houses extraterrestrial spacecraft. The theory also alleges the facility is used for the study of alien beings. Area 51's secretive nature fuels speculation about its involvement with extraterrestrial phenomena. Eyewitnesses report observing unusual aerial phenomena in the vicinity of Area 51. Alleged sightings and secretive activities near Area 51 have led to speculation about extraterrestrial involvement. These accounts fuel ongoing debates regarding the true nature of Area 51's operations. The alleged alien spacecraft is housed within a secure hangar at Area 51 for research and analysis. The spacecraft's unconventional propulsion system is a primary focus of study, involving detailed scans and theoretical modeling. Material analysis of the spacecraft's hull reveals an unusual composition, exhibiting properties not found in terrestrial materials. Bob Lazar's testimony about working on alien technology at Area 51 has fueled its mystique. Lazar's claims have significantly contributed to the prevalence of alien conspiracy theories. Area 51's association with alien technology is largely attributed to Lazar's controversial narrative. Area 51 is theorized to be a reverse engineering facility for advanced technology. The purpose is to understand and replicate technology from unidentified flying objects. Reverse engineering involves analyzing the structure and function of alien technology. Reverse engineering involves deconstructing an object to understand its design and functionality. Scientists analyze the alien technology to replicate its advanced capabilities and underlying principles. The goal is to understand the alien technology's design, materials, and manufacturing processes for potential applications. Area 51 is theorized to be a site for the development of advanced stealth aircraft. Cutting-edge military technologies are rumored to be secretly developed within Area 51. The development of stealth aircraft involves innovative designs to minimize radar detection. Experimental aircraft testing showcases advanced aerospace engineering. Area 51's research involves cutting-edge aviation technology and design. Footage documents the evolution of experimental aircraft designs and technologies. The U.S. government has historically maintained secrecy regarding Area 51. Official statements have neither confirmed nor denied many claims surrounding the base. This ambiguity contributes to the ongoing speculation and mystery surrounding Area 51. Area 51 has garnered significant public interest, fueling its mysterious reputation. Extensive media coverage has further contributed to the enigma surrounding Area 51. The combination of public interest and media attention amplifies the mystique of Area 51. Area 51's presence in movies, TV shows, and books has cemented its status as a cultural icon. Its portrayal in media often links Area 51 to government secrecy and alien conspiracy theories. Area 51 has become a symbol representing the intersection of popular culture, government intrigue, and extraterrestrial speculation. The mystique of Area 51 attracts tourists to nearby towns. Increased tourism provides a boost to the local economy. Local businesses benefit from the influx of tourist dollars. Skeptical experts emphasize the absence of solid evidence supporting conspiracy theories. Misinterpretation of events is a common factor contributing to the propagation of conspiracy theories. Critical analysis reveals that many conspiracy theories rely on speculation rather than verifiable facts. Unidentified aerial phenomena, sightings near Area 51, may be attributed to atmospheric optical illusions. Advanced experimental aircraft testing can produce unusual visual and auditory effects mistaken for extraterrestrial vehicles. Misidentification of conventional aircraft or meteorological events contributes to reports of anomalous objects. Stringent security measures at Area 51 are implemented to safeguard classified information. Protecting experimental technologies is a primary rationale for the high security environment. The need to prevent unauthorized access and potential espionage necessitates these extensive protocols. The future of Area 51 remains uncertain, shrouded in speculation regarding potential government disclosures. Public interest persists in uncovering the truth behind Area 51's classified activities and historical events. The possibility of full government disclosure regarding Area 51's operations is a subject of ongoing debate and anticipation. Area 51's existence as a military base is a confirmed fact. Numerous theories surround Area 51, ranging from advanced aircraft testing to extraterrestrial encounters. The audience is left to draw their own conclusions based on available facts and speculative theories. The Yonaguni Monument is a large underwater rock formation off the coast of Yonaguni Island, Japan. The monument features unique geometric shapes and step terraces. The origin of the Yonaguni Monument is debated due to its unusual structure. The geological structure is primarily composed of sandstone and mudstone. Sandstone and mudstone are sedimentary rocks formed through the accumulation and compression of sediments. The formation of these sedimentary rocks occurred over millions of years. Tectonic activity can cause fracturing and displacement of rock layers. Seismic events contribute to the formation of sharp angles and flat surfaces in rock formations. Fracturing and displacement result in the characteristic appearance of certain rock structures. Wave action constantly impacts coastal rock formations, initiating the erosion process. Over extended periods, erosion sculpts fractured rock, rounding edges and creating terraced features. The terraced appearance of coastal rock formations is a direct result of continuous wave erosion. Natural jointing and fracturing patterns can cause rock to break along straight lines and right angles. These natural patterns may resemble artificial construction in rock formations. Pre-existing joints and fractures predispose the rock to break in predictable ways. The presence of precise geometric shapes in ancient structures suggests artificial origin. Right angles and parallel lines are geometric features less likely to form naturally in geological formations. The geometric precision of the structure supports the theory of non-natural construction. The stepped terraces feature regularly spaced platforms, indicative of structured design. The structure's form resembles ancient ziggurats or stepped pyramids, suggesting artificial construction. Regularity in the step pattern and platform dimensions implies deliberate planning and potential human involvement. Claims suggest the presence of tool marks on certain rock surfaces. The interpretation of these marks as artificial is a subject of ongoing debate. Geologists and archaeologists hold differing views regarding the origin and significance of these marks. The presence of quarry sites suggests stone extraction for construction. Quarry sites indicate a potential source of building materials. Stone extraction from quarries may have supported local construction efforts. Natural rock formations exhibit various geometric patterns due to environmental factors and geological processes. Tessellated pavements are natural rock formations that display similar geometric patterns. Comparative analysis reveals similarities and differences in the geometric patterns of various natural rock formations. Coastal erosion sculpts unique rock formations through natural processes. Wave action, wind abrasion, and chemical weathering are primary drivers of coastal erosion. Coastal erosion demonstrates the powerful and transformative forces of nature. Tectonic forces generate regular fracture patterns in rock formations due to stress distribution. Fracture patterns vary based on the type and intensity of tectonic stress applied. These fracture patterns provide insights into past tectonic activity and geological history. Geological dating techniques determine the age of rock layers. These dating methods provide a timeline for the Earth's formation. The relative position of rock layers helps to establish a sequence of events. Carbon dating is a potential method for determining the age of organic materials found at a site. The application of carbon dating depends on the presence of organic material. The limited availability of organic material can restrict the use of carbon dating techniques. During the last ice age, sea levels were significantly lower than present day. Lower sea levels during the ice age exposed land that is currently submerged. The exposure of land due to lower sea levels could reveal submerged structures. The timeline illustrates the gradual submergence of structures due to rising sea levels after the last ice age. Post-glacial sea level rise led to the inundation of coastal areas and human settlements. The submergence timeline visually represents the impact of historical sea level changes on coastal environments. The existence of an artificial structure implies the presence of an advanced civilization. Such a civilization would have possessed sophisticated engineering and architectural knowledge. The structure's complexity suggests a high degree of social organization and technological capability. Simulations explore potential stone cutting techniques used in the structure's creation. The stacking methods employed in the structure's construction are visually recreated. Hypothetical construction techniques are simulated to understand the structure's creation. Various theories propose different purposes for the construction, ranging from ceremonial platforms to defensive structures. The structure's design may reflect a dual function, serving both spiritual and practical needs. Understanding the structure's purpose requires considering both archaeological evidence and historical context. Ocean currents around the Yonaguni structure illustrate water flow patterns. These water flow patterns demonstrate the erosive forces acting on the Yonaguni structure. Visualizations show the interaction between ocean currents and the underwater geological formation. Ocean currents transport sediments across the seabed, influencing marine geological structures. Sediment transport by currents shapes underwater landscapes over geological timescales. The continuous process of sediment transport alters the structure and composition of marine environments. Geologists propose natural geological processes as potential origins for specific formations. Evidence from rock strata, mineral composition, and geological dating supports natural formation hypotheses. Geological models simulate natural processes over extended periods, demonstrating potential formation mechanisms. Archaeologists propose that certain ancient structures exhibit characteristics inconsistent with natural formations. Evidence suggests advanced engineering and construction techniques were employed in the creation of these structures. The precision and complexity of these structures imply intentional design and skilled craftsmanship beyond natural processes. Sonar technology is used for underwater mapping and object detection. Remotely operated vehicles, ROVs, allow for visual exploration of underwater environments. Advanced underwater technologies facilitate future research in marine biology, geology, and archaeology. The Yonaguni Monument's origins remain an unresolved mystery. Compelling evidence supports both natural geological formation and artificial construction hypotheses. Further research and investigation are required to determine the true nature of the Yonaguni Monument. The Nazca Lines are geoglyphs located in the Nazca Desert of southern Peru. These lines are etched into the desert landscape, creating various shapes and figures. The geoglyphs' scale and precision suggest advanced planning and execution. The Nazca Desert is located between the towns of Nazca and Palpa in South America. The arid climate of the Nazca Desert has contributed to the preservation of the Nazca Lines for centuries. These lines have been preserved for centuries due to the desert's unique environmental conditions. The lines were initially observed from the air in the early 20th century. Systematic study of the lines commenced in the 1940s. Aerial observation played a crucial role in the initial detection and study of the lines. Geoglyphs are created by removing surface pebbles to expose the lighter soil beneath. The removal of surface material creates a visible contrast, forming the geoglyph design. The resulting contrast is most visible from an aerial perspective. Many geoglyphs depict animals, including the hummingbird, monkey, spider, and condor. Each animal geoglyph is precisely drawn with distinct characteristics. Animal figures represent a common motif among geoglyphs. Some geoglyphs depict plants and trees, reflecting the Nazca people's relationship with nature. Plant geoglyphs illustrate the Nazca people's understanding and reverence for the natural world. These geoglyphs provide insights into the Nazca culture's symbolic representation of flora. Geoglyphs include various geometric shapes, such as triangles, spirals, and trapezoids. These geometric shapes add to the complexity and mystery of the geoglyph site. The integration of geometric forms enhances the overall artistic and cultural significance of the geoglyphs. One theory proposes that specific alignments correspond to an astronomical calendar. These alignments may indicate solstices and other significant celestial events. Simulation demonstrating the correlation between terrestrial structures and celestial movements. One theory suggests the lines were used for religious rituals. The lines may have represented pathways for processions during these rituals. These rituals could have been connected to astronomical events or agricultural cycles. Some researchers propose that certain lines served as markers indicating the presence of underground water reserves. These lines may have functioned as pathways guiding individuals to these crucial underground water sources. The lines potentially acted as navigational aids, leading to areas where water could be accessed or collected. The extraterrestrial theory posits that the lines served as signals intended for extraterrestrial visitors. This controversial theory is largely dismissed by mainstream researchers. The line's purpose remains a subject of debate, with various alternative explanations proposed. Maria Reike dedicated her life to the study and preservation of the Nazca Lines. Reich was a key figure in understanding the significance of the Nazca Lines. Her work contributed significantly to the ongoing research and protection of this historical site. Modern preservation efforts include cleaning the ancient lines to reveal their original form. Mapping the site is crucial for understanding the layout and protecting the lines from damage. Protecting the site involves preventing erosion and minimizing human impact. Vehicle damage to road markings underscores the necessity for robust protection measures. The degradation of road lines due to vehicular impact highlights the importance of durable materials. Implementing strict protection measures can prevent the deterioration of road markings and ensure long-term visibility. Erosion control involves implementing various techniques to minimize soil loss. Barriers are constructed to physically block the movement of soil and water. Drainage systems are implemented to redirect water flow and prevent soil saturation. Modern technology such as drones is employed for detailed mapping. Satellite imagery provides comprehensive monitoring of infrastructure conditions. Aerial surveys enable the creation of precise maps and infrastructure monitoring. Carbon dating is employed to ascertain the age of artifacts discovered near the lines. The analysis helps determine the construction period of the lines. Radiocarbon dating measures the decay of carbon-14 to estimate the time of origin. Archaeological digs near the Nazca Lines are yielding new artifacts. These discoveries provide insights into the Nazca culture. Ongoing research continues to uncover more about the Nazca civilization. The Nazca culture, renowned for its distinctive pottery and textiles, thrived in the same era as the Nazca Lines. Nazca pottery is characterized by its polychrome decoration and detailed depictions of animals, plants, and mythical beings. Nazca textiles demonstrate advanced weaving techniques and feature stylized representations of similar motifs found in their pottery. Understanding the beliefs and practices of the Nazca people provides context for interpreting the purpose of the lines. The Nazca Lines are deeply connected to the religious and spiritual beliefs of the Nazca civilization. These lines likely served as pathways for ritual processions and ceremonies honoring their gods. The Nazca Lines are not unique. Similar geoglyphs exist worldwide. The scale and complexity of the Nazca Lines are unparalleled compared to other geoglyphs. Worldwide geoglyphs vary in form, purpose, and cultural significance. Tourism at the Nazca Lines balances accessibility with the need for preservation. Designated viewing platforms provide access to the Nazca Lines while minimizing environmental impact. Flights over the Nazca Lines offer aerial views, but are managed to prevent damage to the site. Researchers hold diverse views regarding the purpose and meaning of the Nazca Lines. These varying perspectives have fueled ongoing debates and discussions among experts. The significance of the Nazca Lines remains a subject of scholarly contention. Future research aims to employ advanced technology for detailed analysis of the lines. Detailed analysis may reveal new clues about the origins of the lines. Simulation technology allows for the recreation of the line's formation under various conditions. The Nazca Lines remain a captivating enigma, inviting further exploration and study. Ongoing research seeks to unlock the secrets of the Nazca Lines. Further study is needed to fully understand the purpose and meaning of these ancient geoglyphs. Hessdalen Valley is geographically located in Norway. The Hessdalen Valley is the setting for frequent unexplained light phenomena. The frequency of these unexplained light phenomena makes Hessdalen Valley a unique location. Statistical data reveals the frequency of Hessdalen Lights appearances over time. The duration of Hessdalen Lights events varies, as shown in the distribution analysis. Intensity patterns in the Hessdalen Lights suggest potential underlying mechanisms. Observed lights commonly exhibit a color spectrum ranging from white to yellow and orange. Typical light shapes include spherical and elongated forms. Movement patterns of these lights often include hovering, pulsating, and flashing behaviors. The ionized dust cloud theory proposes that certain atmospheric lights are formed by interacting clouds of ionized dust particles. Ionization of dust particles results in the emission of light, creating visible atmospheric phenomena. The interaction and movement of these ionized dust clouds in the atmosphere lead to the formation of various light patterns. Simulated chemical reactions within dust clouds can produce light emissions. The composition of local soil influences the potential chemical reactions and resulting light. Visualization tools allow for the analysis of potential light-emitting chemical reactions in dust clouds. The piezoelectric effect describes the generation of electricity in certain materials under mechanical stress. Piezoelectricity arises from the displacement of positive and negative charges within a material's crystal lattice. Stress-induced electricity in rocks containing piezoelectric materials can generate light. Geological fault lines are mapped to identify areas of tectonic stress. Tectonic stress along fault lines can contribute to piezoelectric effects. Mapping fault lines helps assess the potential for piezoelectric energy generation. Atmospheric plasmas can form through the ionization of gases. Ionization leads to the emission of light within the plasma. Simulations demonstrate how atmospheric plasmas could form in natural environments. Radon gas emissions from the ground can contribute to the ionization of the atmosphere. Ionization occurs when radon emissions strip electrons from atmospheric gases. Sufficient ionization can lead to the formation of atmospheric plasmas. Local magnetic field anomalies can be mapped to visualize variations in magnetic field strength. These magnetic anomalies may influence the behavior of lights within the environment. The appearance of lights can be affected by local magnetic field disturbances. The Hessdalen Lights phenomenon may be explained by a combination of multiple theories. These theories include atmospheric plasma, piezoelectric effects, and combustion of airborne dust. The complex interplay of these factors contributes to the unpredictable nature of the lights. Electromagnetic radiation emitted by lights is analyzed to identify specific frequencies. Frequency patterns in electromagnetic radiation can provide clues about the origin of the light source. Analysis of electromagnetic radiation involves identifying and interpreting these distinct frequency patterns. Spectroscopic analysis identifies the elemental composition of a light source by examining its emitted light. The unique spectral signature of light reveals the specific compounds present within the light source. Detailed analysis of light emissions allows for precise identification of elements and compounds. Isotopic analysis of soil and air samples is conducted to determine the origin of materials. Analyzing isotopic ratios helps identify potential sources of energy contributing to observed phenomena. The process involves precise measurement of isotopic variations to trace the source and nature of materials. Current research projects aim to understand the nature and origin of the Hessdalen lights. Methodologies include spectral analysis, magnetic field mapping, and atmospheric particle studies. The goals are to identify the light's composition, energy source, and environmental interactions. The Hessdalen Automatic Measurement Station, HAMS, project utilizes automated sensors to gather data. HAMS collects data on the Hessdalen lights phenomenon and environmental conditions. The automated sensors provide continuous long-term monitoring of the Hessdalen area. HAMS collects environmental data, including temperature, humidity, magnetic field readings, and light intensity. The collected data provides insights into environmental conditions and trends. Analysis of HAMS data facilitates informed decision-making based on real-time environmental monitoring. Multispectral imaging captures light across different wavelengths. This technique reveals details not visible under normal lighting conditions. Analysis of these spectral images provides enhanced data for object identification and assessment. Statistical correlation analysis examines the relationship between environmental factors and light phenomena. Environmental factors such as weather and seismic activity are analyzed for potential correlation with light appearance. The analysis aims to identify statistically significant correlations between specific environmental conditions and observed light characteristics. Several unresolved questions remain regarding the true nature and origin of the Hessdalen lights. Challenges in data collection and analysis hinder the development of a comprehensive understanding. Further research and advanced analytical techniques are essential to unravel the mysteries surrounding the Hessdalen lights. Local weather patterns, such as temperature inversions, can influence the visibility of the Hessdalen lights. Temperature inversions trap cooler air near the ground, creating a lens effect that can magnify or distort the appearance of the lights. Changes in atmospheric conditions can affect the behavior and intensity of the Hessdalen lights. Ball lightning represents one alternative theory, positing a luminous, spherical, atmospheric phenomenon. Unexplained atmospheric phenomena are explored through scientific observation and data analysis. Scientific rigor remains paramount when investigating unconventional atmospheric theories. Comparative analysis reveals the strengths and weaknesses inherent in different scientific theories. Areas of agreement and disagreement among scientists are central to theoretical advancement. Systematic comparison facilitates a deeper understanding and refinement of scientific models. Future research will focus on developing new sensor technologies for data acquisition. Advanced data analysis techniques will be crucial for interpreting complex datasets from new sensors. The integration of new sensors and data analysis will drive innovation across multiple research domains. The Hessdalen lights remain an unexplained phenomenon, prompting ongoing scientific inquiry. Continued investigation is crucial to understanding the nature and origin of the Hessdalen lights. Unraveling the secrets of the Hessdalen lights may reveal new insights into atmospheric physics or unknown energy sources. Plato's dialogues, Timaeus and Critias, introduce Atlantis as a powerful naval civilization. Atlantis existed millennia ago, predating many known ancient societies. These texts describe Atlantis as an island nation located beyond the Pillars of Hercules. Various theories suggest Atlantis was located in the Atlantic Ocean. Geological features and underwater structures provide potential evidence of the lost island. These theories often align with interpretations of Plato's descriptions of Atlantis. Some theories suggest Atlantis was located in the Mediterranean Sea. The Thera eruption, Santorini, caused widespread devastation that may have inspired the Atlantis myth. Volcanic events such as the Thera eruption may have contributed to the legend of Atlantis' destruction. Alternative theories suggest Atlantis could have been located in the Black Sea. Some theories propose Atlantis was situated in Antarctica prior to continental shifts. South America is another hypothesized location for Atlantis, based on cultural similarities in ancient maps. Plato described Atlantis as having a complex political system. The Atlantean political structure featured a hierarchy of kings and nobles ruling different regions. Corruption within the Atlantean system led to internal strife and, ultimately, societal decline. Atlantis maintained a powerful military force, capable of conquering vast territories. Advanced weaponry played a crucial role in Atlantis' military dominance. Naval power was a key component of Atlantis' military strength. Atlantean society possessed advanced technology, including sophisticated engineering systems. Their agricultural advancements allowed for efficient food production and environmental control. Advanced navigation systems enabled the Atlanteans to build impressive cities and control their environment. Atlantean architecture was characterized by its grand scale and innovative designs. Unknown materials and advanced building techniques were utilized in Atlantean construction. Intricate canals and fortifications were integral components of Atlantean city planning. Some theories propose that the Atlanteans utilized unique energy sources to power their civilization. Crystal technology may have been one of the advanced energy sources employed by the Atlanteans. Geothermal power could have also served as a potential energy source for Atlantean cities and technologies. Atlantean transportation systems included advanced ships capable of long-distance travel. Atlantean technology possibly included flying machines for exploration and military campaigns. These advanced transportation technologies facilitated trade and military operations for the Atlantean civilization. Atlantean agriculture achieved high efficiency through advanced irrigation systems. Crop rotation techniques were used to maximize food production. Efficient agriculture supported a large population and stable economy. One theory posits that Atlantis was destroyed by a massive natural disaster. Potential causes include earthquakes, tsunamis, or volcanic eruptions. These catastrophic events could have caused the island to sink into the sea. One theory suggests Atlantis collapsed due to internal strife and corruption. Overexploitation of resources could have weakened Atlantean society. Weakened by internal factors, Atlantis became vulnerable to external threats or natural disasters. One theory suggests Atlantis was destroyed in a war with another civilization. This conflict may have led to the destruction of Atlantis. The war could explain Atlantis' eventual disappearance from historical records. Underwater structures such as the Bimini Road have been proposed as potential evidence of past civilizations. The Yonaguni Monument is another underwater formation speculated to be evidence of advanced ancient construction. The origins and nature of these underwater structures are subjects of ongoing scientific debate and scrutiny. Analysis of core samples from the ocean floor provides clues about past geological events. Sediment composition analysis can reveal potential evidence of submerged landmasses. Core sample analysis helps determine if a large island existed in a particular area. Legends of lost cities destroyed by natural disasters are common across many cultures. These myths often share themes of societal hubris and environmental destruction as causes for the city's demise. The parallels in these legends suggest a universal cautionary tale about the consequences of unchecked ambition. Flood myths are common across many cultures, often describing a great deluge that destroys civilization. These myths may share connections with the Atlantis story, suggesting a common origin or cultural exchange. The prevalence of flood myths indicates a widespread cultural awareness of catastrophic inundation events. Atlantis is often interpreted as a philosophical symbol, representing human ambition and technological advancement. The story of Atlantis serves as a cautionary tale about the potential dangers of unchecked power. The narrative emphasizes the importance of balance and sustainability to avoid societal downfall. Atlantis is often viewed as a utopian society, symbolizing an ideal civilization. This ideal civilization possesses advanced technology, social harmony, and environmental stewardship. The utopian interpretation of Atlantis inspires visions of a better future for humanity. Many scientists are skeptical about the existence of Atlantis due to the absence of concrete evidence. The Atlantis narrative is often viewed as a philosophical allegory rather than a historical account. Reliance on mythological accounts without empirical support fuels skepticism within the scientific community. Alternative explanations for the Atlantis myth involve misinterpretations of historical events. Exaggerations of natural disasters contribute to the Atlantis narrative. Cultural storytelling significantly influences the development and perpetuation of the Atlantis legend. Archaeological investigations explore potential sites related to Atlantis. Advanced technologies such as sonar are used to map the ocean floor. Underwater robotics assist in the exploration and documentation of submerged sites. Analyzing artifacts from potential Atlantis sites provides insights into the culture, technology, and daily life of its inhabitants. Artifact analysis helps determine if the discovered objects are related to a lost civilization. The study of artifacts can reveal the level of technological advancement and societal structure of a civilization. The Atlantis mystery continues to fascinate, blending history, mythology, and scientific speculation. Atlantis' story serves as a reminder of the rise and fall of civilizations. Whether a real place or a philosophical allegory, Atlantis inspires enduring curiosity. The Antikythera mechanism was discovered at this underwater shipwreck site, highlighting its archaeological significance. The underwater environment has preserved the Antikythera mechanism, offering insights into ancient technology. This location provides crucial context for understanding the function and purpose of the Antikythera mechanism. The Antikythera mechanism fragments are heavily corroded, indicating their age and exposure to harsh conditions. The fragmented state of the mechanism reveals its complex internal structure, hinting at its original functionality. Despite their condition, the recovered fragments offer valuable insights into ancient Greek technology and engineering. A complete 3D model of the Antikythera mechanism is displayed. The model provides a visual representation of the mechanism's original form. The 3D model illustrates the complexity of the Antikythera mechanism. The animation reveals the internal gears of the mechanism. The intricate arrangement of gears is highlighted to show their precise positioning. The interaction between the gears demonstrates the mechanism's functionality. The main dial features scales and markings that represent different astronomical cycles. These scales and markings are essential for tracking and predicting celestial events. The dial integrates multiple astronomical measurements into a single, comprehensive display. Gear ratios are calculated to accurately represent the relative movements of celestial bodies. The size and number of teeth on each gear determine the rotational speed, mirroring orbital periods. By adjusting gear ratios, complex astronomical relationships can be simulated and visualized. This simulation illustrates a mechanism for predicting the solar cycle. The simulation accurately forecasts solstices, marking the longest and shortest days of the year. The simulation also predicts equinoxes, when day and night are of equal length. The simulation accurately predicts lunar cycles. The simulation models the moon's phases. The mechanism of the simulation allows for the prediction of lunar phases. The simulation accurately predicts the positions of planets in our solar system. The simulation demonstrates the relative orbital speeds and positions of inner and outer planets. Planetary positions are calculated and displayed in real time, showcasing the simulation's predictive capabilities. The device accurately predicts solar eclipses by calculating the moon's orbital path relative to the Earth and Sun. Lunar eclipse predictions are determined by tracking when the Earth passes directly between the Sun and Moon, casting a shadow on the Moon. The prediction device uses complex algorithms to account for orbital variations and ensure precise eclipse forecasting. The calendar mechanism tracks both solar and lunar cycles. Solar calendar tracking is achieved through a series of precisely calibrated gears. Lunar calendar tracking displays lunar phases and their correlation with the solar cycle. The mechanism's plates are inscribed with detailed astronomical information. Calendrical information is also present, indicating the mechanism's ability to track time. These inscriptions reveal the sophisticated understanding of astronomy and timekeeping in the mechanism's design. The reconstruction process begins with scattered fragments of the mechanism. Over time, the fragments gradually assemble themselves into larger subcomponents. The final stage involves integrating the subcomponents to complete the fully reconstructed mechanism. Material analysis provides insight into the technology employed in the mechanism's construction. The materials used are analyzed to understand the technological capabilities of the era. Analyzing materials reveals the technological context in which the mechanism was developed. The Antikythera mechanism is situated within a timeline of ancient scientific and technological advancements. This timeline provides historical context by showcasing concurrent scientific and technological achievements. The timeline illustrates the level of scientific and technological sophistication during the Antikythera mechanism's era. The mechanism functions as an astronomical calculator, predicting celestial events. It also serves as a calendar, tracking the passage of time through celestial cycles. The device combines astronomical calculations and calendrical functions into a single integrated system. Subsequent centuries experienced a decline in specific technological knowledge. The reasons for this technological regression are complex and multifaceted. The loss of this knowledge had profound and lasting impacts on subsequent technological development. Modern research endeavors to comprehend the intricacies of the Antikythera mechanism. Efforts are focused on reconstructing the Antikythera mechanism to understand its functionality. The research aims to reveal the operational principles and historical significance of the Antikythera mechanism. X-ray imaging reveals the internal structure of mechanisms without causing damage. This non-destructive testing method allows for detailed inspection and analysis of internal components. X-ray imaging is used to identify defects, assess structural integrity, and ensure quality control. Computational modeling simulates a mechanism's operation. Simulations enable hypothesis testing within the computational model. Visualization of computational models provides insights into complex systems. Simulation visualizes various precision gear manufacturing methods. The simulation demonstrates the high level of precision required in gear manufacturing. Different manufacturing methods are simulated to achieve optimal gear performance. Contemporary astronomical theories provide frameworks for understanding celestial phenomena. Models in astronomy are constructed based on theoretical foundations and observational data. The connection between theories and models allows for continuous refinement and validation of astronomical knowledge. The Antikythera mechanism holds significant cultural value as a symbol of ancient Greek ingenuity and scientific achievement. Its discovery has reshaped our understanding of ancient technological capabilities and astronomical knowledge. The mechanism serves as a tangible link to the past, illustrating the sophistication of ancient Greek science and engineering. Future research aims to fully reconstruct the Antikythera mechanism's original design and functionality. Advanced imaging techniques will reveal more inscriptions and details hidden within the mechanism's fragments. Ongoing studies seek to understand the full extent of the mechanism's astronomical and calendrical capabilities. The Antikythera mechanism stands as a unique and remarkable artifact of ancient technology. Its complexity and precision are unparalleled for its time, demonstrating advanced understanding of astronomy and engineering. The Antikythera mechanism's legacy lies in its demonstration of early scientific ingenuity and technological prowess.